Okay, today's lesson is 9-2 parabolas. We have graphed parabolas back in chapter 4 earlier in the year, but now we're going to learn a little bit more about parabolas. And one of those first things we're going to learn is something called the geometric definition of a parabola. It means really where does it come from geometrically. A parabola can be defined as the set of all points in a plane that are the same distance from a given point, called the focus, and a given line, called the directrix. So if you look over here at my picture, okay, here is my parabola. This point right here in the center is called your focus. And I don't know how to spell focus. Try that again. This is your focus. This line down here, this dotted line, is your directrix. Now don't get this confused. The other dotted line you should be familiar with. That is your axis of symmetry. Don't know why my program does that. That's your axis of symmetry, and that's the one where if we fold that parabola along this line, then it will match exactly on both sides. It's basically a mirror image. Okay, I'm going to talk about the other blank in a second, but I want to show you a website that I really like. It's about, I know, it's me. Anyway, interactive parabola. So as we said, we've got a focus and we have a directrix. This line right here is my directrix. And if you see the distance from the focus to a point is, in this case, 8.14. The distance from the point to the directrix is 8.14. So as I get this point and I drag it around, you should see that the distance is not changing, because this is the set of all points. When I find all those points that are equidistant from the focus and the directrix, then all of those points make this shape, which is called our parabola. So another thing that you need to know about a parabola is that there is this line right here. It's in red, so we'll go on red. It is called the lattice rectum. And not necessarily a pleasant name. However, comes from the Latin, which means straight side, if you've had any Latin. And one of the things that can help you understand, it's basically the side of a parabola. It's really the width of the parabola through the focus. Okay, and that's going to be an important thing that we're going to talk about a lot as we go through our study in this section. Okay, so remember what you did before with parabolas. You learned y equals x squared, and that is a parabola that went up. And then a little bit later, this was like before this year. Then a little bit later, we added some things. We put an a in front, x minus h quantity squared plus k. And you knew that h and k, h shifted it left and right, k shifted it up and down, and a, basically the number, told us how skinny or how fat our parabola was going to be, and then the plus or minus told us whether or not it was going to open up or down. So what is different and what is new that we're adding is we're going to kind of define that a. Okay, so this a is equal to 1 over 4p. Or if you really want to think of it, p is equal to 1, poo, I don't know why I did that. Go away. P is equal to 1 over 4a. Don't particularly like this one as much. However, you're going to see, well, let me write it. So the forms of the equation that we have, okay, we have form, what you're used to. Y equals, instead of a, we're going to write 1 over 4p, x minus h quantity squared plus k. Now, just like I talked to you about the a, what does the a really do? Okay, the a, or this particular number right here, in which case it's not a anymore, it's p. If p is greater than 0, then we know our parabola will open up. If p is less than 0, then my parabola will open down. Okay, now the next thing, our vertex is still the same. Our vertex is H, K. Now, let's keep going down here. I know, CK would love me, all my sound effects. And then we go to the axis of symmetry. That is the same, X equals H. And I will tell you this, I mentioned this to people, but the axis of symmetry, if you notice up here, is the part that's squared. And you're going to want to know that when you get into the other side here. Okay, so we have an axis of symmetry. Actually, I'll write it over here. It's the part of your equation that is squared. That's the one that's going to tell you what your axis of symmetry is. Okay, then we have our focus. Now, what is important to remember about the focus, it is always inside, why does it do that? Always inside the curve. Okay, the other thing is what you've got to remember, and this is what may be a little bit new, is that P represents the Stop it, Bradley. Golly, stop. Where'd it go? All right, we'll try this. Seriously. P is the distance from focus to the vertex. Very, 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 very important. I can't even say how important that is for you to remember that. Okay, I'm going to give you some equations, but I'm going to let you see how easy it is to remember. So X equals K plus P is if it's vertical. Then we have something called the Directrix. Okay, again, Directrix is associated with P. P is the distance from Directrix. Don't do that. To the vertex. And if you can think about this, it's always perpendicular. Perpendicular to the axis of symmetry. So if the axis of symmetry is X equals H, this is going to be Y equals something. And what it's going to be opposite direction from that. So it's Y equals K minus P. Okay? And in the future, just so that you know, a lot of people tend to forget this. When I ask for the lattice rectum, I'm asking for the length of that lattice rectum. And the length of your lattice rectum, the length, it always has to be positive. That's why its absolute value is 4p. Okay? Now, an alternate form that you're going to see, you might see it a lot next year, so I kind of want to show it to you and tell you that either one of these forms is acceptable. And that is to basically have that squared one all by itself, this up here to have it all by itself. So if I move the k over, actually, I want to put that first, move the k over, that would be y minus k, and then the 4p over, that equals x minus h quantity squared. So you have the squared part all by itself. Makes it easy to see that this number right here, when it's in front of the one that's not squared, is the length of your lattice rectum. Okay, and as I mentioned before, this is the width of the parabola through the focus. Okay, now let's go talk about this other one. Or why was there another column? That's the big deal. Well, the deal is that it could change. My x and y could change, and it would be x equals 1 over 4p y minus k quantity squared plus h. Okay, and in this case, if p is greater than 0, it doesn't open up, it actually opens to the right. And if p is less than 0, it's not going to open down, it's going to open to the left. So the variable changed, which one is squared changed, but our vertex does not change. K is always with y, h is always with x, so my vertex is still hk. And as I mentioned before, okay, my axis of symmetry is the squared one, so which one is squared? So now my axis of symmetry is y equals k. All right, my focus, It's not going to, if this one's opening left and right, then the focus, the y coordinate's not going to change, but the x coordinate is. So it's going to be x plus p comma k. And that means that this one, if it's y equals, this one's going to be x equals, and it's always the opposite of what that looks like. Now, and last but not least, our lattice rectum. Does it change? Absolutely not. It's still the absolute value of 4p units. And if I write that, it's going to be 4p. Or if I take this equation and rearrange it, 4p times x minus h equals y minus k quantity squared. Okay, so the other thing that I need to tell you for this book, so you need to look at your book and you got to figure out which way they've defined it and what they call it. Okay, but what we have had in the past, okay, is the vertex form of the parabola was y equals a times x minus h quantity squared plus k. I need to pause. Okay, I'm back. So this was the vertex form that we learned in chapter 4. Okay, and then our standard form was y, well, I don't have a color, so let me get a color, was y equals ax squared plus bx plus c. Okay, so why am I telling you about this? Because I know you're going to love to hear this. But in this chapter, okay, they just want to confuse you. But they are now calling this right here the general form. And they're calling this the standard form. So when you are reading, and this is something that will change from book to book, but the concepts behind it don't change, okay? So vertex form or standard form in this chapter, this right here, which you knew as vertex form, is now standard form. And this right here, what we called in chapter 4 standard form, is now general form. Okay, so just want you to be aware of that so that when you see, as we do this next problem here, you'll understand what's going on. So it says, write y equals 4x squared plus 16x plus 34 in standard form. So what is that standard form? Y equals a times x minus h quantity squared plus k. All right. So what process do we get to use to do that is what you're very familiar with, hopefully, and that is something called completing the square. So I'm going to remind you what we do. So we have y equals, when you complete the square, your coefficient of x has to be a 1. So I have to factor out that 4. So that's going to give me x squared plus 4x plus something to complete the square. The 34 is being moved over here. And if I add, I can either add to both sides or I can add and then subtract from the same side. And inside that parentheses, everything has been multiplied by 4. So what number am I going to put in here? Half of 4 is 2. And I square it and put it in both blanks. So when I come back, that's going to give me, this is going to be easy to factor, y equals 4 times x plus 2 quantity squared. Just to refresh your memory, this without the exponent, this without the exponent, and it always takes that sign right there. So you're getting something from every term. And then 34 minus 16, of course, is 18. I didn't write that correctly. So that is my standard form of the parabola. Identify the vertex. Vertex is the opposite of what's in there, so it's -2, the same as the outside. The axis of symmetry is that squared part, axis of symmetry, x equals -2. Put a little colon there. And the direction of the opening, it's the x is squared, which is what we knew about before, and it's positive, so I know that it's going to open up. And so that answered all of those questions. All right, the next kind of thing you got to be able to do, so you're going to be practicing your completing the square. And now let's talk about graphing. And I'm going to talk about making sure that you know what the vital information that you need. And really, if you do it from the graphing, y'all, it is really easy. Okay, so from here, let's go grab this guy. X minus 1 quantity squared equals 8 times y minus 2. So the first thing you would do would be to find your vertex. And my vertex is hk. This, of course, is h is always with x, k is always with y. So that's going to give me 1, 2. If it's in the parentheses, it's always the opposite of what it looks like. The next thing I'm going to do before I start doing things, I'm going to go which variable is squared. The x is squared, it's positive, there's no negative sign, so I know my parabola is going to open up. Okay, so let's go with plotting my vertex at 1, 2. And the next thing I have to do, I know it's going to open up, so it's going to do something like this, but I need to know where the focus is. This is all you have to graph for me now. Okay, so this right here tells me that is 4p. So if 4p equals 8, then p equals 2. And so this is my vertex. And if I go, I know it's opening up. So if I go up 2, that is my focus. And if I go down 2, let me see, I haven't set this up, so bear with me. If I go down 2, it's right here. This is my directrix. Back to my pen. All right, and so I have a focus, I have a vertex, this is my directrix. And the equation, of course, of that is y equals 0. This is kind of why I show you. If you just, the main thing that you have to know is different is this right here, okay? Because everything, you know how to find the vertex. And that p tells you the distance from the vertex to the focus. That's p right there. Or vertex to the directrix is p. Okay, so what else? We said that's the lattice rectum. That's the width of the parabola through the focus. So from my focus, I'm going to go 1, 2, 3, 4 units this way. And 1, 2, 3, 4 units that way. And that is what I'm going to do to graph. And that's all you got to do. Okay? So the vital information, if they ask you, this right here is the length of your lattice rectum. If I ask you the lattice rectum, it's there. If I ask you the focus, you go plot it. You know how to give me the coordinates, 1, 4. Okay, so any of that, I could ask you. The axis of symmetry, of course, is right here. You don't have to plot it, but it's x equal to 1. Axis of symmetry, directrix, you know the coordinates of the focus, and the lattice rectum. I want to see those endpoints when you graph it, but you don't have to label them for me. You just need to give me the length of it. Okay, let's go do another one. We have y minus 2 quantity squared equals negative 4 times x plus 1. So the first thing I'm going to do is find my vertex. Vertex is hk. Now, I have a y squared, which means my parabola is going to open left or right. And since it's negative, I know that it's going to open to the left. Okay? So, from here, I'm going to go plot negative 1, 2. And the next thing that I did from there, because I know how to plot anything, that's my vertex. I know it's going to open that way, so I'm going to put the V right there. Okay? P, I'm not going to worry about the negative. The negative told me it went to the left. So, 4P is equal to 4, which means P equals 1. Which means if I go 1, the focus is always inside the curve. That's how I know that this is where the focus is. Okay? Oh, don't do that to me. This is also the length of my lattice rectum. So I know if I go here, that's one endpoint, and that's one endpoint, and then I'm going to know that my parabola is doing this. Kind of missed that. Let's try that again. Oh, he doesn't do the whole thing. Oh, well. Let's try that again. Good enough. Y'all got the idea. Okay, I am going to go ahead and plot the directrix. It is 1 unit away, so my directrix is right here. Okay, that's my directrix. Axis of symmetry is straight through here. I'm not going to plot it. Most of the time you don't really have to. Okay, but to answer any of those questions, okay, I plotted all that information. Okay, and if you plot it, then it makes it easy. How long is my lattice rectum? 4 units. Where's my focus? Negative 2, 2. Vertex, negative 1, 2. This is my directrix, which is x equals 0, which is opposite from y equals Stop moving. Try that again. Y equals 2. Okay. I got 2 more examples, and then we're going to be done. If you're good with it, you can stop watching. All right, this next one says, write the equation of the parabola described below. Okay, so I have 2 problems and I have 2 graphs. So basically it's the same direction, so this problem, we don't have to worry about it right now because it's down below. All right, so let's get going with this next one that says, I have a vertex at 1, 3. So 1, 1, 2, 3. There's my vertex. I'm going to put it right here. And my focus is at 1, 5. 1, 2, 3, 4. So my focus is right here. Okay? Now, if that's my focus, I don't have to, oh, it does say graph. It does say you don't have to graph it. Okay. But if that's my focus, that's enough to tell me that my parabola is going up. And if my parabola is going up, then I know that my x is going to be squared, and the rest of it's going to look like this. I happen to think this is an easier one to deal with. So, x minus h. Well, what's h? Well, there's h right here, and there's k. So it's going to be x minus 1 squared equals something times y minus 3. I need to find out what p is. Well, p is right here. That's p. P is the distance from the vertex to the focus. So if I put 2 in there, p equals 2. 4 times p is 8. And there we go. We have it. It doesn't matter. If you noticed I had the squared on this side, it was just easier because I knew that side was going up. It does not matter if you have the 2 sides of this equation flipped. Okay? To finish graphing, okay, and again, whatever that is, you're going to have twice that distance on both sides because this is p, but I got 4p, which means I need 2p. So 1, 2, 3, 4. 1, 2, 3, 4. And there's 1/2, and there's the other half, and that's all you need to tell me. If you're interested, I would go 2 units the other way. This is where my directrix would be, and that is y equals 1. Okay, axis of symmetry right here, axis of symmetry, stop moving, x equals 1. Golly, stop. Oh my goodness. X equals 1. All right, we're going to go with it because that's what it is. All right, let's look at the next one. And I think it's the last one. All right, so this time, focus is at 5, 6. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. But that's the right spot. That is my focus. My directrix is x equals negative 2. Okay? X equals negative 2 is right here. Okay? Now, if that's the case, that right there is enough to tell you which way it opens. My parabola has to open this way. Focus has to be inside the curve, can never cross the directrix. This means that y is going to be squared. So it's going to be y minus k squared equals 4p times x minus h. And I can write everything except for that 4p part. Oh, I can't because I don't know what my vertex is. Oh, well. So vertex is, okay, if the vertex is halfway between these two because it's got to be equidistant from both of them. So if this is 5 units away, then this is 2 units away. That's a total of 7, right? So half of 7 is 3.5. So 1, 2, 3. This is where my vertex is. So that makes my vertex. I have to graph it, so I'm not going to write it on there. So I find out that my vertex is at 1.5, comma 6. So I can write my equation. Y minus 6 quantity squared equals, not sure what that number is yet, x minus 1.5. Okay? For p, what is p equal to? Okay, this right here is my p. So p is, well, we just said 3.5, 3.5. And 3.5 times 4 is 14. So this, it's opening to the right, which is positive, so there's no negative. And if it's 14, then I'm going to go 1, 2, 3, 4, 5, 6, 7 this way. And 1, 2, 3, 4, 5, 6, 7, kind of guessing that way. And so my parabola will open really wide. And there we have it. That's your section 9-2 on parabolas. If you have any questions, please come see me or email me. Thank you so much.